Hi, this is Phil at Simply Rhino, and in this video I'm going to take a look at Rhino 8 for Mac. I'll be concentrating primarily on the improved performance, but also I'll look at the new interface and examine how this can be customized. I'll be looking at two areas of performance. First, I'll look at in-viewport display capabilities. So, what it's like to manipulate large data sets whilst modeling and drawing. Secondly, I'll look at rendering using Rhino's Raytraced renderer. These are two areas where it's fair to say that Rhino 7 for Mac lagged significantly behind its Windows counterpart. Before looking at Rhino 8, it's perhaps worth considering why the in-viewport display is compromised in Rhino 7 for Mac. In the Windows world, many popular 3D modelers, including Rhino, use a graphics pipeline called Opengl to allow for hardware acceleration via a graphics processing unit or GPU. Higher-end Intel-based Apple Macs with dedicated GPUs also supported Opengl, although perhaps not as well as Windows. Over time, however, Apple has moved away from Opengl in favour of their own proprietary graphics pipeline called Metal. With the advent of the Apple Silicon-based machines, starting with the M1 processor that launched in November 2020, Apple effectively stopped hardware support for Opengl. This happened at an unfortunate time for Rhino users, as Rhino 7, that relies on Opengl, also launched in November 2020. As Apple gradually replaced its range of Intel-based Macs with Apple Silicon processors, there were, of course, fewer new products capable of supporting Opengl. Rhino 8 for Mac runs natively on Apple Silicon hardware and has a completely new display pipeline built for Metal, and McNeil have done a great job in implementing this. Let's look first at in-viewport performance on an Apple Silicon-based product. The machine in question here is a 2023 16-inch MacBook Pro with an M2 Pro chip, and this, and its newer M3 variant, represents a good choice for Rhino 8. I'm using our familiar truck model for these tests. This is a large 1.36 GB file and contains meshes, solids imported from SolidWorks, and lots of native Rhino NURBS geometry. The polygon count command reveals that there's over 10 million polygons. In order to compare Rhino 7 against Rhino 8, I used the test max speed command, and the full details of the tests, which are better controlled than the screen captures shown here, can be found in the accompanying PDF document. Link in the description below. Let's look first at wireframe mode in Rhino 7, and you can see that the results are quite choppy. In testing, we only managed 3 frames per second, whereas the same scene in Rhino 8 achieved a result of 68 frames per second. So that's over 22 times faster. Moving on to rendered mode, Rhino 7 achieves 3.75 frames per second, whereas Rhino 8 can manage 32 frames per second. That's an uplift of 8.5 times. Finally, let's look at the shaded viewport, which is perhaps the most used viewport mode in Rhino. Here you can see that Rhino 7 produces a very slow result, just 2.5 frames per second, whereas switching to Rhino 8 yields 53 frames per second, so Rhino 8 is slightly over 21 times faster. Of course, test results don't paint the whole picture. Working with the model, zooming, changing the view angle, etc. causes real problems in Rhino 7, as we can see here. Parts of the model drop out and the mouse response is very delayed. This is, of course, due to the lack of any hardware support for Opengl. working on the same model in Rhino 8 with the metal display pipeline leads to very smooth results. There's no dropouts or stuttering, and the overall feel, mouse feedback and performance is comparable to a high-end Windows solution. So, we can see that there is a significant speed increase on an Apple Silicon-based machine in all the Viewport modes tested here. But what happens on an older Intel-based Mac? To find out, we ran the same tests on a 2019 iMac Pro. This is a high-spec Intel Xeon-based machine and features an 8GB Radeon Pro Vega 56 GPU, which supports both OpenGL and Metal. Looking first at the wireframe display mode, Rhino 7 achieves just under 10 frames per second, whereas switching to Rhino 8 sees this increase to just under 60 frames per second. So, on the iMac Pro, the wireframe mode is 6 times faster. Moving on to the rendered viewport mode, Rhino 7 struggles somewhat and reports only 3.5 frames per second, whereas switching to Rhino 8 sees this increase to just over 20 frames per second. So the rendered viewport mode is 5.75 times faster in Rhino 8. Finally, testing the shaded viewport mode in Rhino 7 shows a result of just under 10 frames per second. And this is 3 times faster in Rhino 8 that reports just under 30 frames per second. Let's now consider Raytraced rendering. Rhino uses the Cycles Raytraced rendering engine that is developed by the Blender team. Historically, this has been able to use hardware-accelerated GPU rendering via CUDA, optics, and OpenCL. In simple terms, CUDA and optics are specific to NVIDIA's GPUs, and OpenCL was supported for rendering with AMD graphics cards. As most Apple Macs after around 2015 shipped only with AMD GPU hardware, then OpenCL was effectively the only choice for Mac users. As mentioned previously, Apple decided to prioritize development of their Metal pipeline rather than support third-party solutions. And, with this in mind, the Cycles development team decided not to implement OpenCL going forward on the Mac platform, and this left Blender and Rhino 7 Mac users with a CPU-only ray-traced rendering option. Metal support was eventually added to Cycles, and Rhino 8 carries this over, significantly improving ray-trace performance. In terms of speed, our tests showed that on the iMac Pro, the ray-trace viewport was around 3.5 times faster in Rhino 8 over Rhino 7, and the offline render was around 4.6 times faster. Switching to the M2 Pro powered MacBook Pro, our tests showed that the ray-traced viewport performance was 5.5 times faster in Rhino 8 compared to Rhino 7, and the offline render over 7 times faster. To compare the two machines, the MacBook Pro, as tested, produced the same offline render twice as fast as the iMac Pro when both were running Rhino 8. So we can see that in our tests, Rhino 8 is faster on both the Apple Silicon and Intel machines, with the biggest speed increases coming with Apple Silicon. Let's now look at the interface, and this is the default proposition for Rhino 8 Mac. If I switch to a screenshot of the Windows version, you can see that the Windows and Mac products now have a much more unified appearance with the toolbar tabs, sidebars and icons occupying similar positions. The good news is that the Mac interface is now more customizable and different layouts can be named and saved. There's a number of changes and enhancements in Rhino 8, but I'm just going to focus on a few areas that I think might be helpful. On the right-hand side, we now have a single sidebar by default, and this sidebar contains the Properties, Layers, Display and Help panels, and other panels can be added as we'll see shortly. On the left sidebar, there's the Command Input and Tool icons. These icons become context sensitive when, for example, the Surface Tools, Solid Tools, etc. are selected. Underneath these icons we have tabs for Object Snaps and Selection Filters. The Viewport tabs, Modeling Constraints and Settings for Gumball and History are now all at the bottom of the screen by default. The sidebars can be collapsed by left-clicking on this icon, and this is a quick way of freeing up screen space for modeling. Left-clicking again restores the sidebar. This behavior existed in the Mac version of Rhino 7, but now, in both flavors of Rhino 8, when the sidebar is in its collapsed state, I can still access the panels by left-clicking on their respective icons to temporarily pop out the panel, and that same metaphor applies to the left sidebar. If I want to add, for instance, the Materials panel to the sidebar, it's just a case of left-clicking on the gear icon here, selecting Show Panels and picking Materials from the list. To have the tabs at the top of the sidebar rather than on the right, I can again select the gear icon and select Horizontal rather than the default vertical. To change the order of the tabs, I can just hold down the left mouse button over a tab and slide the tab right or left. It's now much easier to pop out toolbars, and, for example, any toolbar that has a grey triangle in the bottom right-hand corner can be expanded simply by holding down the left mouse button on the triangle and dragging out the toolbar. The Toolbar tab sits in what is now called a container. If I pop out another toolbar, you'll see that I can dock these containers. And when I move the container into a position where it can be docked, I'll see these blue rectangles indicating where I can place the container. So to dock on the right-hand side of the sidebar, I'll pick here. Should I want to dock the Solid Tools container underneath the Block Tools, I just drag as before until the appropriate position is indicated. As these docked containers are part of the left-hand sidebar, they will of course minimize when I collapse the sidebar. To release the panels from their docked position, I just drag them away until they become floating containers, and then I can dismiss them by clicking on the cross that appears when I hover the mouse over the top left corner of the container. I'm just going to widen the left-hand side panel slightly so I can see a little more of the layer information before looking at the command history. In Rhino for Windows, there's always been a command history window, the default position of which is above the toolbar tabs. In Rhino 7 for Mac, we were able to show the command history as a panel, but this was fixed as part of the right sidebar. In Rhino 8, the command history sits at the bottom of the screen above the modeling constraints. I can now drag this out, note the open hand icon, and then dock this above the toolbar tabs. It's then a case of just pulling down the bottom of the command history container so that there's 3 or 4 lines of text visible. This makes it much easier to view the feedback from commands such as, for example, if I analyze the length of a number of connected sub-D edges. I'll see in the command history that I get the cumulative length for 12 edges. Having made changes to the default interface, I can now save these by going to the Window menu, selecting Window Layouts, and then Save Window Layout. I can give the layout a name and then save it. I can see the saved window layouts here, and as well as the default layout, there's also a drafting and rendering layout in the standard installation. So that's about the end of what I wanted to cover in this video. Thanks for watching, and please feel free to leave any comments below. If you found this video useful, then please hit the like button, and remember that to keep up with the latest developments in Rhino, you can subscribe to this channel. At Simply Rhino, we offer training for Rhino and all its key plugins, so check out our website for more details. Thanks again for watching, and I'll catch up with you in the next video.